Welcome back from a long feeling Christmas vacation. I know it felt long for me, but was it long for you guys? No, it went by quickly. We have 9 questions here, all related to the 3 chapters that we did since September. The first 3 questions have to do with rational numbers. We have the addition of 2 fraction rational numbers. We have the addition of 2 decimal rational numbers, and we have the addition of 2 um, square roots of rational numbers for the first 3 questions. So for the first one we have, so our first question gives us -3/4 plus 1/6. Now, if that wasn't negative, Abby, what we would do is we would just add it with, we'd say, okay, in order to add 2 fractions together, we need common denominators, yada, yada. The only difference between a grade 7 question, which this would have been without a negative, and grade 9 is the negative symbol. So we're still going to ask ourselves, what is the first multiple 4 and 6 share? And that answer is 12. Now, if you use 24, it's no problem. 24 will work as a common denominator, just means it's not going to be in lowest terms. But by using 12, the equivalent fraction to this is going to be -9/12. And the equivalent fraction to this will be 2/12. Now, from a grade 9 perspective, when you add 2 fractions together that have common denominators, you keep the denominator and you add the numerators, which means -9 plus 2 is -7, which means your final answer for this particular question, what's -3/4 plus 1/6? It's -7/12. In our second question, we have decimals this time. And if we think about what this question says, it could be I owe, because it's with a negative sign, I owe 20 cents. And I have $3.12. So if I owe 20 cents and have $3.12, how much money do I have altogether? That's one way to think of it. Another way is to think of an easier question. So if I had -2 plus 3 non-decimals, what would I do? In both cases, whatever you have more of, in this case you have more positives, you would take what you have more of and you would subtract what you have less of. And since I have 2 significant decimal places in my first number, I'm going to put a 0 there. So $3.12, take away the 20 cents I owe if I pay it off, will tell you how much money I have left over. 2 take away 0 is 2. 1 take away 2 you must borrow. 11 take away 2 is 9. Oh, decimal goes right here, not there. And therefore, if you owed 20 cents and you had $3.12, at the end of the day, you would still have $2.92, or simply 2.92 as a final answer. In the third question, you have 2 square roots of rational numbers, one in fraction form, one in decimal form. I'm going to first solve both in the form that they were given in. So the first one's fractions. Remember, square root means what number multiplied by itself gives you the answer of 4/9, or in this case, what fraction multiplied by itself. It is a perfect square because we have 2 for our numerators and 3 for our denominator. So therefore, what is the square root of 4/9? The answer is 2/3. And what is the square root of 4/100? Or another question would be, what is the square root of 4/100, right? Because 0.04 and 4/100, it's the same number. So again, what fraction multiplied by itself gave us 4/100? The answer is 2/10. So therefore, when I rewrite this question as fractions, I would get 2/3 plus 2/10. How many of you changed 2/10 right away to something else, lowest terms? What would that be instead of 2/10? 1/5. Would it be easier to work with if I used 1/5? Yeah, because your numbers are easier. Do I need to? No. What would be the first multiple 3 and 10 share? 30. So we're going to use 30 here as a common denominator. If you changed it to 1/5, you're going to be using 15, but it doesn't matter. 20/30 plus 6/30 are the equivalent fractions to each. Add your numerators, you get 26. Add your denominators, 30. Because we didn't use 15, we have to reduce that to lowest terms. And we end up with the answer of 13/15. Okay? Does that make sense? Our next 3 questions all have to do with our chapter on exponents. The first question gives us just a bedmass question, but it's not really a bedmass question because it's just addition and subtraction. We do it in the order they appear anyway. So 2 cubed, remember what that means. 2 cubed means 2 multiplied by itself, not 1, not twice, but 3 times. 2 times 2 times 2, which 2 cubed would have a standard form of 8, plus 1 to the exponent of 4 is 1 times 1 times 1 times 1, which no matter how many times you multiply 1 by itself will always be 1. A common mistake there would be what number? 4. A lot of times you see 4, even with the smartest of people. And the next one is the trick part, because remember, this does not equal this, right? When that exponent of 2 is attached to the 5 but not outside the brackets, this would be negative 5 times negative 5, which is a positive 25. And the opposite of 5 squared is negative 25. So this is going to actually be a negative 25. And I want you to notice here, I'll use a highlighter here. This subtraction sign is still a subtraction sign. And this negative sign is a part of that. So we need to use brackets because it is taking away a negative 25. Once we get that, we have 9 take away a negative 25. Most people like to do this, which gives us a final answer of 34. Our next question uses our sign laws that we learned. When a power, in this case the power of 2 cubed, is put to an exponent of 2, that means 2 cubed multiplied by itself twice. Once we have that, we know that if we have a base that we're multiplying, keep the base and add your exponents, and we get 2 to the power of 6. That's one way to think of it, or using a sign, our exponent laws, keep the base and multiply your exponents, so 2 and 3 times 2, which would still be 2 to the 6. Plus, here we have in brackets the multiplication of bases that have, or of powers that contain the same base, and the division of powers that contain the same base. So we can use our sign laws to go 3 squared. If we're going to multiply, not 3, 4. If we're going to multiply 2 powers that have the same base, we can actually add them together. And the reason why is because 3 squared is 3 times 3 times 3 to the 4 would be 3 times 3 times 3 times 3. In this case, we are multiplying 3 by itself 6 times, which means this law works. So 3 to the power of 2 times 3 to the power of 4 is 3 to the power of 6, divided by 3 cubed. Jack, what is your rule for dividing powers that have the same base to different exponents? What do? You keep the base and do what to the exponents? Correct. So therefore, as a final power, it would be 3 to the power of 3. So now that we've simplified that down to 2 simple powers, we're just going to think of it in standard form. 2 to the power of 6 is 2 multiplied by itself 6 times, or 2, 4, 8, 16, 32, 64. Correct? Plus, 3 times 3 is 9. 9 times 3 is 27. So in standard form, we have both of those. And therefore, ergo, our final answer will be 91. Not that big. You still got 91? Yeah. Does my way make more sense? Probably. That's using the purpose of this question. The purpose of the question was for you to realize that that could be simplified using sign laws, and that this could be simplified using sign laws, and we could get it down to this, which can go down to this, which can get down to here pretty easy, right? That was the purpose of that question. Our next question is about as easy as you get. What is any base to an exponent of 0 is what number? Always 1, right? So no matter what our base is, anything to the power of 0 will always be 1. And if you multiply 1 by itself 46 times, what are you going to get? 1. Not 6, no. So therefore, in standard form, this answer will just be the number 2. Exactly. If I can't give you an easier question than 1 plus 1 equals 2, there is no such thing easier than 1 plus 1 equals 2. So that technically is the easiest question I could possibly give you. The next one is your definitions. What is a term? A term is a mathematical expression of a number or a variable or the product of numbers and variables. So for example, we could say that 2 is a number. That's a term. X is a variable. That's a term. Or 2x, which is the product of 2 and x, is a term. Or negative 3xy squared is a term because it's the product of negative 3 times x times y times y. So a term is a mathematical expression that is either a number, a variable, or the product of numbers and variables. The degree of a polynomial is determined by examining all of the terms in an expression and then determining which term has the highest degree. Whatever term in an expression has the highest degree, the whole term. So the easiest way is to look at this trinomial. Okay? The degree of this polynomial, this is a three-term trinomial polynomial. And you know what? Just to make it a polynomial more than three terms, I'll put a plus a y in there as well. How many terms are there? Abby, how many terms? 4 is right. What's the degree of the first term? Jelly, what's the degree of that term there? 2. So we're going to put a little arrow here and say the degree is 2 because the degree is determined by the variables within the term, the sum of the exponents on the variables in a term. So since that only has one variable x, its degree is 2. In the second term, there's a variable, which is good, x, which is good. What is the exponent on that x, Selena? Is it a 0 or is it a 1? A 1. So it has a degree, because this is a 1 there, a degree of 1. 4 has no variable, therefore it can't have a degree because there's no exponents on the variables that don't exist. And this y has an invisible 1 and has a degree of 1. So within that polynomial, each term has a degree of 2, a degree of 1, a degree of 0, and a degree of 1. What's the degree of the polynomial? 2. The degree of that polynomial is determined by the highest degreed term. And finally, a trinomial, what is it? A trinomial is simply a mathematical expression with 3 terms. Easy as that. Is there 2 more questions? Yeah, there's 2 more questions. Here we have, I'm going to make it a little bit bigger. Let's see if I can make it a little bit bigger without screwing this up. Let's see. There we go. That's better. Here we have a trinomial plus a binomial. And what we're really doing when we add polynomials together is we gather like terms. So within this expression, what are usually the terms we gather first, Jack? Do you remember? Which one should we gather first if we're going to add these together? We want to add together the terms that have the highest degree, which in this case is going to be our x squareds, correct? So if I add a negative 3x squared to a negative 5x squared, remember what that would look like. A 2x, this is an x, this is an x, this is 2x. Negative 3x squared would be these 3 here, right? That's negative 3x squared, and then plus 4. So if I think about that first term, that's what it would look like, 2x minus 3x plus 4, plus negative 5x squared minus 3. Is everyone okay with that picture to represent that addition, right? Abby, does that make sense? So when we look at that, if I gather my x squareds, am I going to make any algebraic 0 pairs with those? No. How many x squareds do I have when I gather those? Negative 8 of them, right? Negative 8x squareds is my first one. Those are gone, those are gone. Or numerically, those are gone, and those are gone. What's the next one I'm going to gather? X's. Are they positive or negative? So we're going to put plus 2x. Now those are gone pictorially, and those are gone numerically. And finally, when I add my constants together, what's a 4 and a negative 3 get? 1. So we're going to put a positive 1 here. Or those 4 and those 3 make a positive 1. Or those 4 and that negative 3 makes 1. And our solution is negative 8x squared plus 2x plus 1. When we subtract them, again, this is kind of small, so I'll make it a little bit bigger here. When we subtract them, what's the easiest way for us to do that? Hayden, what do you do when you subtract polynomials? What's the easiest way? Easiest way. Keep flip change. So if I gave you the grade 7 question of this, we agreed that yes, you could subtract them, or you could keep flip change to get 6. Easier. So for this, I'm going to keep the first one. I'm going to change it to addition. I'm going to use the opposite of the second trinomial, which is going to be a positive 3x squared, a negative 5x, and a positive 1. That's the opposite of the trinomial. Once I have that, gather like terms, that's going to be 7x squared. No other x's than that, so negative 5x. And those two is going to become negative 1, and that's my solution.